Welcome back to the See It in Action demo series. Today, we are going to show you how you can use Cirrus Data Cloud to migrate not just block storage and hypervisors, but your unstructured data. We will be walking you through a complete file migration end-to-end using Cirrus Data Cloud, from deployment to moving the files to data integrity verification.
Hello, it is me, Maggie. You probably remember me from all those block migration demonstration. Yes, this demonstration is about our unstructured data migration capabilities, but our file and object migration is built on top of the same exact platform that powers block and hypervisor migration. Same CMC, same cloud platform. All the AI integrations and automations that you probably heard from me before applies here as well. I will come back later in various parts of this video to show you how specific things work with technologies that you are already familiar with. If you are new here, welcome.
Actually, we previously created an introduction video that covers the entire Cirrus Data product family and talks about how unstructured data migration fits into the platform. Please feel free to check that out for a complete high-level picture on our technologies. I will put a link down below. But for this video, we are going to focus on showing you an end-to-end demo. So, this is Cirrus Data Cloud. Let me give you a quick refresher on the platform, then we will jump right into the demo, just in case you are new to Cirrus Data. Cirrus Data Cloud is our data mobility as a service platform. It is a single platform that manages all of your data migration needs at scale. Under this management plane, we have Cirrus Migrate on-premises, or CMO, which is our SAN migration physical appliance that migrates data between fiber channel and iSCSI storage arrays. And then we have a software version of that, Cirrus Migrate Cloud, or CMC, which you can install on any Linux or Windows host to migrate any block storage. Physical, cloud-native, virtual disks, any block storage. Of course, this Cirrus Data Cloud control plane can be a cloud service, or we also have a private edition for air-gapped environments where you can self-host the entire stack, including the management plane. But either way, your data never leaves your data center. So these are our block migration capabilities. Now let's see how files and objects data mobility works under the same platform and same CMC software.
Remember, file migration shares the core platform as block migration. All these access controls, alerting, reporting, project management, APIs, agentic AI collaboration, deployment process, troubleshooting process, all these enterprise features automatically apply to unstructured data as well.
Now let's see it in action. This is the setup we have prepared for today's demo. Cirrus Data Cloud works with any storage your host can reach. That includes local file systems, NFS on Linux hosts, and SMB shares on Windows hosts. Our storage integrations can assist you in connecting your hosts to your network shares, but you can also connect and mount the file systems yourself, and CMC will still work the same way since it is automatically protocol aware. We will get into those options when we set up the migration. Here, we have a Linux host, and we are going to use it as a migration worker. We have our source dataset pre-mounted under MNT/file migration source, and an empty file system is also mounted here as destination. Our host has access to both directories, and that is all we need for today. Data will be migrated from the source to the destination.
Since this is just the same CMC software that our block migration users install on production servers, you are free to install this on any supported Windows or Linux host. It can be a client host, but most likely you will dedicate virtual machines for migration purposes. The CMC software is identical to what is used in block migration. Migrations driven by these hosts and your data, just like the block migration, are not cached on these hosts, and they are synchronized directly from the source to destination. So, no matter you are using cloud service or private edition, your data never leaves your internal network. The same logic applies when you install CMC on a different host, to migrate remotely with a different storage location through a stable and secure connection between them. You will see more of that later when we are deep diving into our migration options.
Okay, anyways, our host is prepared and our dataset is ready. Let's get into the demo. The first thing we need is a project. So we'll come to Cirrus Data Cloud and create a new project. I'll call it File Migration. Here, you can see the available product types, and today we'll select Unstructured Data Migration alongside CMC. With this option enabled, you can see that a new Unstructured Data Migration option is now available on the side menu.
Unstructured data and block migrations can coexist within the same project. You can always edit the project and enable the unstructured data option.
Next, we need to install CMC on our host. To install it, I will come to our host list and locate the installation command. Note that there is a checkbox at the bottom to enable unstructured data migration. This must be checked to enable file and object migration capabilities on this host.
Now this is the same CMC software that we used across Cirrus Data Cloud for block migration. The deployment and outbound-only connectivity model is identical. So all your security settings, network settings, or your automations that massively deploy CMC at scale will automatically work as is.
Okay, I will copy the installation command and paste it in the shell. CMC will install and register to Cirrus Data Cloud all by itself. And this same command can be used on as many hosts as you want, so you are free to use any automation of your choice to deploy CMC at a massive scale. While we are using a Linux machine for this demo, the process for Windows is identical. Regardless of your source operating system, the migration process later on will remain the same. Let's head back to Cirrus Data Cloud, and our host now appears on the registered host list, which means the installation is complete. For scalability, you can deploy as many hosts as you want. While they are all registered to Cirrus Data Cloud, the migration is taking place directly on the host. This way, you can horizontally scale your migration as much as you need. From the host details, we can see the network configuration, OS version, performance, and other information about your host. Under the storage devices, we see our pre-mounted file migration source and our file migration destination. That is exactly the same setup we prepared. Remember, a migration worker can be any Linux or Windows machine that can access your source and destination files. We are just like an application on a client host that consumes your files. Now, let's go and create the migration. From the project navigation menu, I'll go to Unstructured Data Migrations. This is where you can see all of your file and object migrations. Right now, it is empty since we haven't created any migration on this new project yet. So let me click on Create Migration. From here, the wizard will walk us through a step-by-step configuration. We will select the source storage, destination storage, synchronization behavior, data filters so that we can migrate only the data that we need. We will then configure the automatic synchronization scheduling, QoS, and throttling schedule. We will go through all of them here.
Yup, I know. That's a lot of options, just like our block storage and hypervisor migrations. But the good news is, for our experienced users, our OpenAPI compliant REST API, CLI, MCP server, has complete coverage of all these capabilities. The use of the UI is completely optional. Also, we have Migrate Ops, which is our purpose-built first-party automation platform, where you can drop a YAML configuration, and with just one click or one API call, we will execute all your migrations precisely according to our Migrate Ops recipes. We will be adding Migrate Ops recipes specifically for unstructured data migration scenarios as well.
Well, since this is a demo, we will stick to the UI for now. First, we will pick our host, HT Ubuntu 2201, as the migration worker. This is the host we deployed earlier. Next, we have to choose how this migration runs. There are two options, local migration and remote migration. We are using local migration today as the source and destination are both accessible from this single host, and the whole migration runs in one place. But in other cases, like migration to cloud, or cloud repatriation, or migrating to a location with long latency, we also have a remote migration capability where you can use one host on the source side and one host on the destination side to access the storage, and we will transmit the data directly between the two hosts using our optimized host-to-host or H2H connection, which has encryption, data reduction, and other advanced optimization built in. It is also worth noting that H2H connection is bidirectional. The direction you set up the connection does not dictate which way data flows. Host A can connect to host B, but data can move A to B, B to A, or both. At the same time, that matters when your network only allows connections in one direction, but your migration needs the data to flow the other way. For example, when migrating to cloud, connecting from on-premises data center to cloud may be a lot easier than the other way around. So this way you can simply have an outbound secure connection and move data back and forth. This is especially helpful for cloud repatriation use cases.
And yes, this is the same H2H connection we use in remote migration for block storage and also in every single hypervisor migration. The same channel, just carrying unstructured data this time.
Coming back here, I'll switch back to local migration and continue. Next up is selecting the source storage. We will choose File System. Then, under File System, there are two options, which is Local Directory and Connected Network Storage. Local Directory is for storage that is already mounted on the host. You can mount your NAS storage exactly like how an application client would. Of course, the host and the user must have to have proper access permissions to all the data that you want to migrate. And yes, you can also migrate your local file systems as well. Alternatively, you can come to Connected Network Storage. And this is where Cirrus Data Cloud storage integrations would manage the NAS connections for you. We are going to use our previously pre-mounted storage for this demo to keep things simple, but let me show you how this storage integration works. From our project, we can go to our Integrations Goodies page. Under File Storage, we have a generic NFS and SMB integration. We are going to continue adding more product-specific integrations so that all you need to do is to provide the management credentials to those popular storage arrays, just like our block migration integrations. So here, I will just use the generic NFS integration. I could give it a name, the server address, save it, and now it shows up under our enabled integrations, and it is ready to be used across all your migrations across this project. You only need to do this once for each storage.
If you are familiar with the storage array integrations for block migration, integrations here is similar like how Cirrus Data would handle the auto-allocation of the storage devices for you. But in this scenario, we are connecting to NFS servers or SMB shares based on the information and credentials provided in the integration. Once we add more product-specific integrations, we plan to have additional capabilities, including allocating new shares, automatically figuring out the access rules, and more.
Now, back to the wizard. Since we haven't connected anything yet, we click on Connect Storage and select our previously enabled NFS integration here and enter the export path. This will allow the platform to handle the mount for us. Yet from this point onwards, the rest of the migration flow is exactly the same, whether you are choosing local directories or connected network shares. Let's come back and I will go with local directory today. Next, I can type in the path manually or hit the browse button here to navigate through the host file system. Let me find /mnt and pick the file migration source path. It was validated with a green check mark, which means that the platform confirms it can reach this path on the host. Moving forward, here we can select only specific paths to migrate, and we can see the full directory structure from our source for you to choose from, like databases, documents, engineering, and so on. But most likely, you are going to migrate the entire share. Even with the sync everything option, you can still optionally apply data filters in a later step to exclude specific files or patterns that you don't need to migrate. For today, I will go with sync everything. And one more thing, we do have a file path privacy mode. When enabled, file paths are anonymized before they come to Cirrus Data Cloud. The platform still tracks every operation, you still get full statistics, but the actual paths stay private to your hosts, just like your data. This is useful for sensitive data where even the file path is considered confidential. Next up, destination, and it is very similar to source. I will select File System, Local Directory, and click on Browse. Then find our file migration destination. After validating the destination, it confirms with us the synchronization path mapping. If your destination directory is not empty, this validation process will warn us. So, source is /mnt/file migration source. Destination is /mnt/file migration destination. Note that the current version of CMC only support like-to-like migration. NFS to NFS of the same version. Same for SMB to SMB. More cross-protocol synchronization capabilities will come in later versions. Moving on to the next step. This is where we configure how the synchronization engine actually behaves. These settings control what happens every time a synchronization pass runs, how it handles new files, changed files, deleted files, and what metadata it preserves. The first thing is the synchronization mode. We have the synchronize option, which keeps the destination fully synchronized with the source. So if a file is removed from the source, it gets removed from the destination too. And we have the copy only, no deletions option, which only copies new and changed data, but never removes anything from your destination. I will keep it at synchronize. Next, we have the metadata handling. Full metadata synchronization copies all file metadata, including timestamps, ownership, permissions, extended attributes, everything. CMC is also protocol aware. So depending on the file system, it will copy all the relevant attributes as well, such as the NFS4 ACLs or the SMB ACLs. The other option is data only, and it copies just the file content. This may be useful in some cases when you are migrating to a platform with a different metadata model. I will keep it at the default option to do a full migration. And then we have object filters. Let me show you each one. First, we have the exclude files by path, where I can enter industry standard glob patterns to skip specific files or directories. Something like star.log to skip every log file, or star.mp4 to skip every mp4. Here we also provide instructions on how to specify the patterns. These syntax should be sufficient for you to specify any combinations of file patterns you need. Next, we have exclude files by size, where I can set minimum and maximum thresholds. You can use this to control what files you want to move by size. Then we have skip recently changed data, where we can skip files that were modified within the last hours. This is useful when you want to exclude actively changing files until closer to cutover. Skipping these files allow you to optimize network resources and also licensing cost as well, since you are not syncing data that is constantly being changed. So in this scenario, you will come back and change the filter when you are getting close to cutover. All these filters can be updated at any time and it will take effect on the next sync pass. For this demo, I will keep all filters off to migrate everything. After filter, we have the scheduling. Before we set up the schedules, let me dive deeper into our technology here. CMC's unstructured data capabilities are powered by a synchronization engine that is designed and built completely from the ground up. It does not rely on any open tools like rsync or robocopy. There are many reasons.
The major reason is that we need to build an engine that is more efficient and scalable than any other available tools, where parallelism can be maximized in a way that the entire synchronization process is a fully asynchronous pipeline that utilizes all the resources that's available to us, like a well-oiled machine. Another major reason is that we need to maximize the efficiency of large files resynchronization using our block migration technologies. Because migrating a large file is exactly like migrating a block device. And because of this, differential synchronization is not a feature. It is by nature, we always migrate only the parts that need to be migrated. And as a bonus point, since our licensing is based on data transferred, these differential syncs translate directly into cost savings.
And because of this, you can schedule automatic synchronization passes as frequent as you wish to be. Of course, you can also trigger synchronization passes manually using the UI or API too. But if you are using the schedule, out of the box we provide various scheduling options: hourly, daily, weekly. And if you need more advanced option, you can even provide your own cron expression and you can make it as complex as it needs to be. You can add many different schedules and they will all work together. For example, hourly syncs during business hours, combined with a nightly full speed sync and a different schedule on weekends. Yada yada yada. Okay, I am going to skip this, since we are going to just trigger the syncs manually during the demo. Moving on, quality of service. Here, you can control and throttle how fast your migration job moves. You can either control this globally, or you can set a schedule. You can define time slots across the week, each with a maximum synchronization speed, different speeds for different times of day, and separate schedules for on weekends, or even on Fridays if your operational windows look different on those days. These options allow you to configure the optimal migration speed for your environment down to the minute on a weekly schedule. QoS settings are fully dynamic. You can update it anytime you want via UI or API. For this demo, I will leave QoS at default and let sync run at full speed. Next, you can also optionally set up automation hooks that runs before or after each synchronization pass. This mechanism is powered by MigrateOps that we introduced earlier, our first-party automation platform.
Using same mechanisms as block storage cutover automation and workload modernization automations, these hooks can be based on our library of predefined actions like managing processes, adjusting mount points, sending HTTP calls, or you can also provide your fully customized scripts. They can run on the source host, the destination host, or even hosts that aren't part of this migration, as long as they are registered to the same project. This way you can use this mechanism to coordinate your migration lifecycle with the client hosts that's using the same storage.
We will be saving these for other demo scenarios. Moving on, and here's the final review. Everything we just configured is here. Source is /mnt/file migration source. Destination is /mnt/file migration destination. Schedule is manual. Sync behavior is full metadata synchronization, and all filters are off. And at the bottom, there is the usage and licensing note that tells us migration usage is metered based on the amount of data actually transferred to the destination. Remember, since our synchronization engine is always differential, only the changed portions of files count toward usage, just the blocks within the files that need to be migrated. Everything looks good. Let's create the migration. And it is going. The first synchronization pass has already started. A synchronization job has 3 major phases. The first phase is data discovery, which is to locate all the current data you have in your source and destination storage. The second phase is file or object scanning, which is to make decisions on what needs to be synchronized. Then third, of course, is the synchronization phase, where we will copy all the data and metadata attributes. And like we previously mentioned, all these are running together like a well-oiled machine. This fully asynchronous pipeline ensures that our migration workers are never waiting on each other and are always contributing to progress while staying lean on resource. Just being multi-threaded is not going to cut it. Here, the engine is discovering all the files on the source, and we have about 109,000 files in our case. We can see the scanning rate and current progress visible right here as it runs. The process will scan the file attributes and determine whether synchronization is needed. Then, over here, you can see every action that needs to be done by our synchronization process. While synchronization is happening, you can also click on Show Live Progress to see which individual file is being synchronized and track its progress. Since this is our first pass and the destination started completely empty, every single operation here is a create. On later passes, you will see a much more complex picture. During the file scanning phase, CMC also profiles and performs various analysis on your dataset. For example, here you can look at the type of data that you have, whether you have mostly VM files that are data reduction friendly, or you have mostly video files that likely require more raw storage. You may also want to know whether you have mostly big files or tons of small files. For our demo dataset, we have files ranging from 64 bytes all the way up to about 36 megabytes, with a median of around 152 kilobytes. Age analysis is also an important one. You can see how old your data is and how often they get accessed. Knowing the distribution of hot, warm, and cold data can be very useful when it comes to storage planning and deciding your migration strategy. We are very actively enhancing the information that this process provides. Of course, just like everything else, all of these can be API-driven. These analyses are running on every pass automatically, but you can also run a scan-only pass first prior to any actual migration. To run a scan-only pass, you can come to the action and select Discover Changed Data. You can run this first or at any time when you want to know the data that requires synchronization. Let me trigger one now, and let's see what happens since our initial synchronization has completed. Here we go. All 109,000 files are scanned, and there are about 3 gigabytes of changes detected on the source. From the breakdown here, we see that 10,000 files has been changed, 5,458 new files have been created, and 5,458 files were deleted from the source. And of course, our file analysis has been refreshed as well. You can always go back to previous passes and review the earlier analysis. Alright, now let me sync again to bring the destination up to date. Remember, Pass 2 just told us about the 3 gigabytes of data changed since our first sync. So let's see what the engine actually has to move this time when I trigger a sync manually, and we'll wait for Pass 3 to complete. Again, this entire process is identical to any other passes. So here, we see that our 15 gig is synchronized just as expected, but also, look at this. We have a 47% of data reduction. Remember how we talked about our engine is differential sync by nature? Using our deep expertise in block-level migration, our engine always only transfers the portions of file content that requires synchronization. With 3 gigabytes of changes on our source, there is only about 1.5 gig actually moved. We can also see the breakdown of synchronization operations on this pass, so we know how much was updated, created, and deleted. And remember, our licensing accounting is also based on this number, so this granular change detection can translate into direct migration cost savings as well. Let's now have a look at our license. Right here, we started off with 2 terabytes of license capacity, and after migrating a 15 and more gigabyte dataset across multiple passes, only 8 gigabytes of license is consumed. We can see that subfile changes only consume license on the modified portions.
And whether you are triggering these passes manually like we just did, through Migrate Ops Automation, REST API, or your AI agent managing the migration through the MCP server, this licensing model stays the same, so you can trigger sync as often as you like.
Now the data is fully synchronized on the destination, but we are not quite done yet. We still need to validate what we move matches exactly with what was on the source. So over on the Data Integrity tab, there are two functions here. The first thing is data verification. This process goes through every file on the destination and confirms that the file content matches exactly what was migrated. This is your confidence check before cutover, and you can run it as many times as you want. Another thing is the chain of custody report, which will come after. Let me trigger a data verification. The verification pass is now running. The verification rate is over 400 megabytes per second. The number of total data being verified is updating live as we go. And it's done. We have all 109,000 files verified with 15.77 gigabytes of data and 0 errors. I can click into the details to look for the full progress breakdown.
Now, for those of you coming that are familiar with our CMO appliances for SAN migration, yes, this is the exact same verification process that you already know. It is powered by the same patented dynamic data integrity verification technology, except now it applies to files and objects verification too.
Now that verification is complete, I can generate a chain of custody report. This is the formal audit record of your migration. Every single operation we have ever run on this migration, like creates, updates, deletes, verifications, gets logged into one document. The fingerprint of every file operation is also provided for full traceability. Let me request one, and the report is now generating in the background. We have 240,000 audited operations included in this report. Since it actually contains the fingerprint of your data, this chain of custody report is stored directly on the destination storage, so it never leaves your environment. Each report also comes with a checksum on the report data itself. This checksum is stored in the CMC configuration, so you can use this to confirm that your report data is not altered externally. Let's take a look at the report. You can access the report through a built-in terminal viewer command that comes with the CMC installation. Or you can directly open the CSV at the destination storage path using any method you like. Each row of the report comes with the timestamps, action type, file information, and data checksum. You can trace through every action that has taken place. Alright, one last check before we wrap up. Let me validate from the host itself, straight from the file system, outside of Cirrus Data Cloud. The file counts match. Directory structure also matches. The full tree from our source is replicated to our destination storage. And you can see that every attribute came across too. Each color here represents different file type, permissions, ownership. CMC is automatically protocol aware, so if it is a NFS storage, SMB storage, all the applicable metadata like the NFS4 ACL attributes will get migrated as well. Before we end this, you can also generate a migration report, which is different from the chain of custody report. While chain of custody is the audit trail of all migration operations, migration report contains the operational summary of the migration and is stored within Cirrus Data Cloud for you to view anytime. It contains everything about the migration, including project overview, migration overview, source and destination details, full configuration, and complete pass history. This report sticks around even if the migration is later deleted. You can trigger more synchronization passes as often as you like. When you are ready to cut over, simply put your applications to read-only, do one final synchronization pass, and configure your clients to consume your data directly from the new storage. When you are done, you can complete the migration.
Remember Migrate Ops, our automation platform, where we have many Migrate Ops recipe that one-click automates different migration scenarios. We are also going to add specific Migrate Ops recipes for unstructured data under the same platform to facilitate this entire sequence.
And the migration is now marked as completed. Let's do a recap on what we did. We started simple by preparing a migration worker host that already has our source and destination pre-mounted. We installed CMC with a single command. Then we walked through all different migration options, selecting the migrator node, migration type, source and destination configurations, sync behavior, metadata, filters, scheduling, QoS, automation hooks. This looks very complicated, but most of these are just advanced customization. The defaults are more than enough to take you through a basic migration, and that's what we did. We ran the first sync pass and watched the engine build the file analytics while it moved data. After the first synchronization pass has completed, we triggered a new pass and saw our efficiency in action. We had a 47% subfile data reduction. and there were 15 plus gigabytes synced across multiple passes, but only 8 gigabytes of data went across the wire, which is also the amount of license that's consumed. After we're through with the synchronization, we triggered a verification pass and confirmed that data integrity of all 109,000 files with our patented data integrity technology. We generated a chain of custody for auditing, previewed it, and downloaded it. We eventually generated a full operational migration report and completed the migration. Remember, at Cirrus Data, automation is a first-class concept. Everything we did today, all of it can be automated. With Migrate Ops recipes, we are going to bring the same one-click operation you may have already experienced from block migrations, now to files and objects. Combined with our REST API, CLI, Agent Skill, and MCP server working with agentic AI, we are coming close to fully autonomous data mobility. Of course, aside from automation, security, scalability, performance, and verifiable accuracy are the core reasons why we added what you saw today to Cirrus Data Cloud.
Yup, just as they are in the block and virtualization migrations I showed you in the past. So, that is it from us. For more end-to-end migration demos and to stay up to date with everything we're building, head over to our YouTube channel to learn all about it. We will keep bringing you more migration demonstrations like this one, so stay tuned.